I'm going to have you folks try this one on your own. So I want you to take the derivative using logarithmic differentiation. I do expect you to take the absolute value. I do expect you to use the rules of logs to simplify as much as possible before you take the derivative. I'll just remind you that the result may or may not be valid at values that make this function equal to 0. Generally speaking, if you leave it in the form that you get, if you just multiply that y over at the end, in that form, you're going to have the things that would make this function 0 in the denominator. But often you could simplify to get the version that you would get if you didn't use logarithmic differentiation. We're not going to concern ourselves with that. I just want you to get the formula that you get using logarithmic differentiation. I just want to acknowledge that caveat. So pause the video, find the derivative. All right, I've got this worked out here. I just went from calling it f of x to calling it y, and then I said let's take the absolute value because I want to be able to take the natural log, got to get rid of any negatives. Okay, so the absolute value distributes over the multiplication, and for each power I applied it to just the base of that thing. Then I took the natural log of both sides, a step which is legitimate if y is not 0. That work is not legitimate if y is 0. Most of the time this answer would simplify if I were to cancel everything that cancels, ignoring the fact that 0 over 0 isn't actually 1. Most of the time this would simplify to something that's valid even if y was 0. Okay, so everything that was on top I got a positive log. Everything that was on bottom I got a negative log. Then I used the power rule to bring those exponents down and make them coefficients. And then I took the derivative of both sides. We get 1 over y prime. The derivative of the log of the absolute value just gives me the reciprocal. So here we got 2 copies of the reciprocal of sine x, and then times the derivative of sine. Here we got minus 3 copies of the reciprocal of x. Here we got minus 2 copies of the reciprocal of cotangent times the derivative of cotangent. Bump up here, okay, the derivative of sine was cosine. So that first term became 2 cosine over sine x. And then the derivative of cotangent was negative cosecant squared. So this last term becomes plus 2 cosecant squared over cotangent of x. To solve for y prime, we multiply by y. And I just wrote in what y was in terms of x. So here's my formula that works anytime that it's defined and that y wasn't 0. And if I simplify this, most likely the result will work even if y is 0.